Why can dinosaur fossils only be found in a handful of places? Did dinosaurs never exist anywhere else? Dinosaurs ruled the Earth for an astonishing 160 million years. Throughout that unimaginably long span of time, billions upon billions of dinosaurs once lived across the planet. Their footprints stretched around the globe. From the tropical rainforests of the equator to the icy edges of the polar regions, the entire Earth was once their backyard. And yet, only a handful of places on Earth have produced dinosaur fossils on a massive scale. The Badlands of North America, Xinjiang and Liaoning in China, the Gobi Desert of Mongolia, and the Patagonian Plateau of Argentina. Beyond these world-famous dinosaur graveyards, most places on Earth are nothing more than fossil deserts to paleontologists. So where did the remains of those countless billions of dinosaurs go? Today, we're going to solve that mystery. First, let's return to the very beginning. Imagine an 8-ton Tyrannosaurus collapsing onto a Cretaceous plain. Within hours, scavengers would swarm in, stripping every scrap of flesh from its body while dragging its skeleton apart. A few months later, bacteria, fungi, and insects would completely break down whatever soft tissue remained. Within just a few years, bones exposed to sunlight, wind, rain, and air would rapidly weather, crack apart, and crumble into dust. In the end, dust returns to dust. An astonishing 99.99% of dinosaurs completely vanished from Earth's material cycle within just a few years of dying, leaving behind not even the smallest trace. For a dinosaur to become a fossil, it must be incredibly lucky and trigger an extremely rare physical phenomenon: rapid burial in an oxygen-free environment. It cannot die on an open grassland. Ideally, it must perish near the edge of a powerful river, at the site of a massive mudslide, or in an area covered by volcanic ash during an eruption. At the exact moment of its death, or within a very short time afterward, there must be an enormous flood, carrying tons of sediment, mud, and thick layers of volcanic ash, that instantly buries the entire body deep underground. Only when it is completely sealed, inside thick layers of sediment, protected from oxygen, shielded from scavengers, and isolated from weathering, can its bones gain the first chance of beginning the long process of fossilization. This single first hurdle has already eliminated the vast majority of dinosaurs that ever lived on Earth. Now, imagine our Tyrannosaurus rex was extraordinarily lucky and was perfectly buried by a mudslide. The next stage begins. A slow and endless journey of geological transformation. Its bones remain buried deep underground. Mineral-rich groundwater slowly seeps into the tiny pores inside the bones. Over millions of years, minerals such as silica and iron slowly replace the organic material inside the bones. Eventually, the original bones transform into hard stone, with exactly the same shape as the skeleton that once existed. This process is called fossilization. But even at this point, it still faces another deadly geological selection process. The rocks on Earth are divided into 3 major categories. Igneous rocks are formed when extremely hot magma from volcanic eruptions cools and solidifies, such as granite and basalt. If volcanic activity occurs in the layers surrounding a dinosaur fossil, the terrifying heat can instantly burn the fossil into ashes. Metamorphic rocks were originally other types of rocks, but deep inside Earth's crust, they are subjected to enormous pressure and extremely high temperatures, under forces powerful enough to deform rocks and completely rearrange their crystals. The fragile fossilized bones would be crushed, twisted, and destroyed beyond recognition. Sedimentary rocks, on the other hand, are formed when sand, mud, and gravel slowly accumulate in water or deserts over immense periods of time, layer by layer, until they become compressed into solid rock. Examples include sandstone, shale, and limestone. Therefore, only gentle sedimentary rocks can preserve fossils intact. If the bedrock beneath the city where you live is hard granite or gneiss, then unfortunately, even if you dug all the way through the Earth, you would never find a single dinosaur bone. The Earth is an astonishing 4.6 billion years old. Yet the period when dinosaurs existed on this planet was restricted to an extremely narrow geological window, the Mesozoic era, from approximately 252 million years ago to 65 million years ago, covering the Triassic, Jurassic, and Cretaceous periods. If the sedimentary rocks beneath your feet are extremely ancient, for example, layers from the Devonian period that are 400 million years old, but dinosaurs had not even evolved yet, let alone walked onto land. If the sedimentary rocks beneath you are too young, for example, rocks from the Neogene period that formed 10 million years ago, but dinosaurs had already been extinct for tens of millions of years, destroyed by the asteroid impact. Therefore, to discover dinosaur fossils, the rocks beneath your feet must have formed at an incredibly precise moment in Earth's history, the Mesozoic era. This requirement further reduces the areas on Earth's surface where dinosaur fossils could possibly exist to an extremely tiny fraction. After surviving the first 3 impossible trials, our Tyrannosaurus fossil is finally preserved perfectly, in the right time period, and inside the right type of rock. But at this moment, it may still be buried deep beneath the Earth, possibly as far as 5 kilometers below the surface. So how does a fossil buried deep underground ever make its way back to the surface? The answer lies in plate tectonics and an incredibly long process of erosion. It must first experience powerful mountain-building events, or the uplift of Earth's crust, which pushes layers of Mesozoic rock, buried several kilometers underground, upward like an enormous geological elevator, bringing them closer to the surface. Then nature must unleash wind, rain, water, and rivers through a slow and endless process of erosion and soil removal, layer by layer. The younger soil and rocks, covering dozens or even hundreds of meters above the fossil, are gradually stripped away. If erosion is too shallow, the fossil remains buried underground, hidden from human eyes. If erosion is too aggressive, the fossil stays exposed on the surface for too long, and wind and rain will eventually destroy it completely, turning it into sand. It has to happen at exactly the right moment. Erosion must remove just enough material so that a small part of the fossil is revealed on the surface of a cliff or a hillside. And then, right at that perfect moment, a paleontologist carrying a geological hammer just happens to walk by, noticing an ordinary-looking rock with a slightly different color. This is why the world's most famous dinosaur fossil sites are often found in extremely barren places, deserts, Gobi landscapes, and wastelands where almost nothing grows. Because only in these extremely dry regions, where vegetation is scarce, can rock layers remain completely exposed. Continuous weathering slowly peels away the layers of Earth, revealing fossils to humanity, like opening a mysterious blind box. So why can dinosaur bones only be discovered in a few places? Because it is far more complicated than simply finding a piece of bone. It requires a dinosaur that happened to die in a mudslide, was incredibly lucky enough to become sealed inside sedimentary rock, experienced the precise conditions of the Mesozoic era, and was later pushed back toward the surface by movements of Earth's crust. Then, under exactly the right amount of erosion, it had to avoid being buried beneath forests and destroyed by acidic rainfall. And just before it was finally weathered away into nothing but dust, it had to accidentally enter the field of view of a human being. Every single step in this chain had to happen perfectly. If even the smallest detail went wrong, this geological and physical miracle that lasted for tens of millions of years would instantly be broken, and the fossil would disappear forever, vanishing into Earth's endless cycle of matter. The next time you stand in a museum, looking through the glass at an enormous dinosaur skeleton, please do not see it as nothing more than a pile of dead stones. You need to understand, what you are witnessing is something that nature has delivered before your eyes. After hundreds of millions of years of an unimaginable process of elimination, it is a cosmic-level miracle, a discovery with a probability so incredibly small that it is almost infinitely close to zero.